Hey, how's it going, everybody? Hi. So I'm Chris Nova, and I'm going to be giving a presentation on kops tonight. So we're going to get started. I missed the introduction phase, so a little bit about me. I'm Chris Nova. I work in the community. I'm one of the kops maintainers, and I'm going to be talking a little bit about kops tonight. Public knowledge available as of today. I recently will be joining the Deis team here in Boulder. So that's going to be very exciting. And we're going to be jumping in to essentially learning what I think is the best way to deploy Kubernetes clusters on Amazon Web Services. Gotta breathe. The point of the talk tonight is to sort of touch on everything from the most simple use case that anybody could get a very basic Kubernetes cluster up and running very quickly, and then eventually drill down and build on that to a more complex cluster configuration, which is going to essentially involve privately networked Kubernetes components running in private subnets over an elastic load a couple of elastic load balancers, and then of course with highly available masters for the Kubernetes cluster distributed across multiple availability zones. So we're going to get into a little bit of a cadence to get started, and what we're going to do is we're actually going to deploy all three of these clusters live tonight. So we'll probably spend about 5 minutes on each cluster, and we'll do a quick Q&A after each cluster is deployed, and we'll have the topology up on the board for everyone to look at. So I'll try to do my best to keep everybody on schedule, but if you do have questions, just save them until the cluster's deployed and we have the API server up and running, which is essentially where I am drawing the line for what I sort of consider success criteria for each of these clusters. If we have a socket, it's listening, we're respecting SSL, we can jump in the Kubernetes dashboard. To me, that says deployment is done, and that is essentially where kops draws its boundaries. What happens after that is up to the user. Really, all that kops cares about is getting the cluster up and running. OK. Sure. Is that better? Great. Wow, that's huge. OK. So before we get started, there is a public repository available. I'll put it on the meetup afterwards. And if you guys want to track me down through any of the available ways on the internet, I'm happy to share it. But everything I'll be going over tonight is available here for free. And I do encourage anybody, if you have any questions, comments, or think it can be better, I plan on using this for more speeches in the future. So any feedback is always greatly appreciated. GitHub.com/ChrisNova, my name, /kopsdemo. Sure. From the Uber?
Pushing fixes from the Uber on the way to...
Oh, yes. So yes, I was in the car. We were taking an Uber to Golden, and I had noticed a typo in one of my images, so I jumped on my laptop and committed right before the meetup.
Do you have the Wi-Fi guest password?
The Wi-Fi, it's written up there on the board. Jazzy something. 77 Twins, I think.
So catchy. Jazzy 77 Twins.
It is. OK, so to get started, we have, I really think we're only going to have enough time to go through the first three. But if anybody is interested in the last one, which will be running a highly available Kubernetes cluster on a subdomain, it's pretty much the exact same as the one above, just with some route propagation in Route 53. I'm happy to have a private session offline or even get together at a later date and show you guys how to do that. It's 99% the same. But we'll start, again, like I said, simple use case, getting more and more complex as we iterate through these. Tonight, it is important to call out, we will be doing everything with kops version 1.5.0 beta. So I think this was officially released, I want to say, not yesterday, but the day before, is when Justin actually pushed this release. So we've been working on 1.5.0. We went into alpha at the beginning of this month, and we've been iterating through, I think, 4 alpha releases, and now we're into beta. When this will actually become an LTS, I don't want to really say to a date, but it should be probably in the next 15 to 30 days, plus or minus, as long as nobody agrees to hold me to that. So anyway, we'll be running that tonight. If you do download kops through Brew, I think if you do a Brew install tonight, you're going to grab 1.4.4, which will not, unfortunately, have a lot of the features we're going to be going through. So this is my way of pushing beta on you guys and saying you should use it and try it out. And us in the open source community would love to hear your feedback and hear your use cases and get your experience of how it worked for you. So let's get started. So in each of these folders in the repo, I've put together a little bit of a schematic. And again, it starts off a little, it's kind of vague in this first instance, but I kind of did that intentionally, as I want to get some basic core concepts kind of agreed upon and get the vernacular straight, and then we can start to drill down further into it. If you look in the repo, you will also find there's a convenient shell script that will wrap kops. So essentially, these are all command line flags that we will pass to the kops create cluster command. So after you get the command line tool up and running on your system, you can actually do a kops -- help, and you can see we're going to be running a create, and then nested inside of create, we have cluster, which this is the entry point into kops and creating a Kubernetes cluster. An important thing to call out is this concept of a state store. And I know everybody who is using Terraform is grimacing right now, saying, why are you using a registered state up in the cloud somewhere? Kops uses a little bit different of a paradigm. We actually don't store any information about the resources necessarily, but we store a representation of the cluster itself. How that is manifested into the actual resources in the cloud, we don't care about. And anytime we need to query the cluster, we actually look that up runtime using AWS tags. So we don't ever have the out-of-sync two sources of truth, which one's right in the wild versus what I have on file problem that you might see in other software. So after you get your state store up and running, it essentially works as a virtual file system. There's documentation online, but basically all you need to do is create an S3 bucket. And we'll point to that in the shell script here. I've created one. Domain I own is Nivenly, and I've called it state store. I strongly encourage everybody to version their state store, as versioning your cluster is impeccable if you ever need to fall back, or if you make the mistake that I've made before where you accidentally delete the bucket, you lose everything and you can't recover. So again, kops command line utility, S3 bucket. So here in the shell script, you can see I just do a delete before I run, and then I sometimes will flip this on and off if I need to delete the cluster or if I actually want to do an idempotent create. So here we're going to run a delete on the cluster, which the only important thing we need to remember is the kops name, which is defined above. This is sort of our ID for the cluster, and as long as you have that defined, you'll always be able to track down your cluster in the cloud. And then we are going to run a kops create, and we'll define all the attributes of the cluster. Here we're telling it the name, the state store. We're going to say we want 3 nodes. We're going to tell it we only want to run in one availability zone, which pay attention to this, because as we grow and iterate on this, we're going to be running in multiple availability zones. The masters have their own zone list, so we will actually run the master in the same availability zone, which probably isn't the best practice, but again, this is just a demo. And then these are just good old EC2 instances here. We want to turn verbosity up so we can see what's going on in the logs, and we're going to run Kubernetes 1.5.2. The -- yes is important, because that says first create the cluster configuration in the S3 bucket, and then we're going to tell kops to go ahead and actually apply these cloud resources to through the AWS API. So kops will actually provision AWS for us. If you neglected to add the -- yes, no resources would be deployed. It would be a dry run. We could tell you what we plan on creating, and you could then do a kops update or kops edit cluster, tweak it however you see it best fit, and then you could do and apply that way. For the sake of speed tonight, we're just going to do this in one fell swoop. OK. So let's go ahead and run it. So here is the super great verbose output of a kops log. I strongly recommend piping this to a text file, especially if you're running this on any sort of CI/CD software. But what's happening now is kops is making sense of everything we've told it, validating that against my personal AWS account, and reasoning about how we think would be the best approach to actually deploying a cluster. So we're done. That was it. That was that simple. It's an asynchronous request. The resources are now spinning up in EC2, and there's a binary that's dropped off on every one of the cloud instances that will actually bootstrap Kubernetes. So, I mean, what was that, 15 seconds? I did a little bit of magic here at the end. Please don't ever do this in production, but I'm spitting out passwords and showing them to everyone. Again, just so you guys can see the use case here, but I don't really need to tell you guys you need to keep your secrets secret. So I'm just going to go ahead and drop in the Kubernetes dashboard really quick. Actually, before I do that, we'll give the cluster some more time to come up. Let's look at what we're about to be taking a look at in the actual AWS console. So kops created our state store, created some text files in there that represent the cluster, and went ahead and applied these resources to the cloud. So to me, when I was sort of asking myself the question, if you create a cluster, like, what do new users care about? Like, to me, I want to know how HTTP data gets from the internet to an API, listening inside the cluster, and I want to know what those inside resources look like and how they may or may not be protected. So here's a very, very simple use case, and also potentially a very dangerous use case, depending on how you use it, of course. Security is only as good as your enforcement. So anyway, what we have here is we have two auto-scaling groups. These are important to note because those are married to a concept called kops instance groups, that if you did go in and actually tweak your cluster, you would be able to specify any amount of custom resources you wanted. So how many servers, what size, do we want to mix and match, and any permutations of ASGs you could come up with in AWS. Our masters will be running etcd, and they will be talking through a security group over 4194 TCP both ways over to the nodes autoscale group. Kops has automatically created IAM roles for both of the ASGs, and we have went ahead and poked a hole for port 22 and port 443 to the masters, and port 22 to the nodes. That's important because now we have SSH access to both the nodes and masters that are publicly resolvable through EC2. So if we go into EC2 and refresh, you can see we now have created 4 instances. We can go ahead and validate everything we just looked at that says we should be running in 2 ASGs, masters and nodes, and if we wanted to, we could actually pull up and check out the security groups and see what the firewall looks like as well. And I'm trying to drive both looking here and here, so bear with me. Great, so you can see we've got 443 opened up to the internet, 22 opened up to the internet, 4194 back and forth, and 443 opened over to the nodes as well so they can hit the API. So I'm going to go ahead and say that's been enough time. The cluster has essentially bootstrapped itself, and the API should be publicly listening. A quick test will be trying to deploy the dashboard here. And if all goes well, we should get a response back. Poof, there it went, from Kubernetes. So let's copy our dashboard URL that the shell script spits out for us and see if we got a cluster up and running. SSL. Go through that, grab my password that nobody's looking at, and poof, Kubernetes cluster up and running, publicly available, and every node in the cluster is accessible via SSH. Right? So now we'll go ahead and we'll run the same script, and this time we will stop after we delete the cluster, and that should clean up everything in AWS for us. So it's a very simple use case, very simple cluster. Any questions?
Is the VPC dynamically created at runtime?
Yes. On the note of VPCs, one of the things we hear a lot in the community is, I already have a VPC. Can we take advantage of that? The answer is yes. Yes, you can. There is documentation on it that a really good friend of ours over at ReactiveOps just put together for us. See if I can't find it. So this is getting updated. I think this was last touched 2 days ago. So this really speaks to the fact that kops is a living, breathing project. I log into GitHub every morning, and things have changed since I was sleeping, the night before. So staying up with kops is a full-time job. But yes, here's an example of defining a VPC at runtime. So if you already have one created and you already have it configured and your subnets mapped out the way you like them, you could stick kops in there as well. If anybody wants an example of how to do that afterwards, I'm happy to spin up a VPC and do it. Yes?
In the existing VPC model, can you also choose subnets that already exist in the VPC, or does it have to generate new subnets in the VPC?
So we can generate new subnets in the VPC, and there is a feature, I believe it's in already, that allows you to specify existing subnets. If it's not into 1.5 beta, it will be in there soon.
It is.
It is?
It's in.
Did you merge that?
No, Justin fixed it.
Oh, OK. So yes, it is in now.
If don't correct me, reach out if I'm wrong.
Sure.
I've actually done it, so I know it works.
It does work? OK, I haven't played with it yet, and it was on my list of things to do to look at Eric's PR. Yes, Matt?
We also have a question from the internet. Basically, how did you set up the firewall rules? Were they in the script, or were there defaults in kops?
Yeah, kops created those for us. So there is, again, Chris Love, I'm going to lean on you for this one if you know better than me. There is a way that we've been talking about defining custom security groups, but I don't think that's in yet.
It's not in yet because RBAC and OBAC, and let me so currently the state of the union on RBAC and OBAC, which are two primary, are two primary ways of doing authentication through a different model. They're still work in progress.
Yeah.
That's the way I put it.
So we will eventually be able to define custom security groups as well, but for now, kops does have 22 and 443 are special that they're called out in the source code. Yes?
If you're deploying into an existing VPC with existing subnets, how does it handle the tagging for those subnets for launching ELBs?
Hey, what do you mean? So you're asking how we tag the subnets so we can cross-reference on the ELBs?
Yeah, so you deploy multiple tags. Typically, the subnet needs to be tagged with Kubernetes cluster or whatever. And if you deploy multiple Kubernetes clusters to that same subnet, is it able to handle that?
She's got the networking guy in the back of the room. Sorry. Do you want to take that, Chris, or do you want me to?
I can take it.
I can take it.
You go.
OK. So as it stands today, I don't think running multiple clusters in the same subnet in the same VPC will be supported. I know there's been talk about how we want to handle, if we're using existing resources, making sure that kops does not take ownership of them. And then on that work, we're also going to be cross-referencing that component as well as the how do we handle tagging them. Off the top of my head, I'm sure we'll probably figure out a way of doing dynamic tags on a resource that is owned by kops that can then reference and say, this is existing and please don't destroy. Sure. Yes?
So running kops 144 to create a Kubernetes 1.5 cluster,
Mm-hmm.
what would you like? Would that be fine? Would there be some dangerous bits that you wouldn't be tuned for 1.5 correctly? Or?
I think it's going to be a case-by-case basis, but I do know that kops pulls Kubernetes from the Kubernetes repo, so as long as there's not anything explicitly called out, you should be fine. Any other questions, or you guys want to move on to the next cluster? Great. So moving forward, we're going to be, again, getting a little more complex here. So yes, a little more complex. What we are going to be creating now is essentially the same cluster, but we're going to be running a lot of what the last questions were around are things like subnets and how kops plays with them. But we're going to be dynamically creating all of these resources here at runtime. And we will be creating 4 subnets, which are going to be mapped to a couple of different resources in AWS. The reasoning for this is essentially what we at kops call a private network topology, meaning that for every private subnet, we essentially marry that through a route table and NAT gateway into a utility subnet that is publicly available. So on a networking level, we actually segregate out AWS resources. And this is our first step towards like a hybrid cloud model, right? Or if you just want to secure your cluster even further. So I'm going to go ahead and spin this one up. And while that spins up, we can sort of talk a little bit more about it. So we want to go into single master private. And we'll run that. And as you can see here, very similar shell script as before, but all we had to do was just increase a couple of our kops command line flags. The important ones I would like to call out are we're still running in single availability zones, and we are now using -- bastion, -- topology is equal to private, and -- networking is equal to weave. Thank you to everyone at Weave who's helped make this possible and all the hard work they've put into it. So we'll wait for this to deploy, and we can sort of take a deep dive into what we're about to be looking at in AWS. The first probably important thing to notice is you'll now notice we have these elastic load balancers in front of our cluster. Before, we just had good old-fashioned TCP forwarding from anything publicly available in EC2 straight down to the actual instance itself. Now we've fronted that with an ELB that is a little bit more scalable and will allow us to create dynamically created DNS records that will point to the ELB that will then also still look and feel the same way as the previous cluster did, but none of the resources will actually be publicly available because it will all be going through the utility subnets and then over a NAT gateway and a route table into a private subnet. You'll notice that there is bastion level ASGs in each of the utility subnets. So we have an autoscale group that is married to a bastion, and literally all this thing does is it's just SSH. It's an SSH client and it's an SSH server. And it is able to route and actually talks to the internal resources. And that way we only have to open up the security group to the bastion autoscale in that security group as well. So after we get a cluster up and running, you'll notice one more instance in the pool, which will be the bastion, which is how we gain access to it. Still waiting on kops. This one's a little more involved, and I think we just about doubled our resource creation in AWS. So bear with us. Any questions so far on this?
Why did you switch to Weave?
Yep.
Why did we switch to Weave? That's a good question, actually. So we switched to Weave because at the time, I think we just had the most in-house tribal knowledge on it. And we were able to get the most what we needed when we switched over. Kops does support Calico, I want to say. I think Flannel is on the, I think Flannel's in, Weave's in.
So, you want the list?
Yeah, because again, like I feel like we just get a new one every day.
Catch me afterwards if you want to talk Weave. I'm the troublemaker with that. And really the reason that, the neat thing about Kops is we segregate the word. I harass people about networking stuff. She actually does that with me. We have Weave, we have Canal, we have Calico, and we have Flannel right now. Romano's in talks. They do not support across multiple AZs. I'm not sure what else we could have added by the community.
Sure.
Is it correct to say that if you're running in a private topology, you have to use one of these network overlays right now?
Yes.
Yeah.
Any other questions? Yes? No, you're fine.
So are you doing any sort of instance or ELB health checks against those nodes that are in the autoscale groups?
We do have an ELB health check, yes.
Is that just checking the health B endpoint, or what?
So we don't have any Kubernetes proprietary ELB health checks. All we're checking now, again, I would love to get a health C in there. I would love to do some validation on making sure we have the API server listening, making sure that we have the right number of nodes we think we have, checking logs, et cetera. But we're not there yet. What the health check does look like for now, and help me, I don't do this very often. Load balancers. So we want to check the API and health check. There it is. Thank you.
That's a great point. You don't publish.
So it's just TCP level right now.
Yeah, literally I'm going to publish.
Especially with using the node, what's the node health check payment set that they used?
Well, Chris, do you want to talk about node health check?
I think we could file an issue and probably move on. Yeah. But great question, though. I think it's a meaningful feature we should probably get in. Anything else? While we're waiting for our cluster to spin up? Great. OK, again, horrible practice here. Please don't remember my password. I guess it won't matter. It's going away soon. And let's go ahead and see if our API is up and running. So it's not yet. So the cluster's still being bootstrapped. So this is I wouldn't say a problem, but it's a necessary consequence of running this asynchronously, is there is this moment where kops is sort of doing this magic under the hood, and you're sort of left waiting to see what's going to happen. That's where there's a subcomponent of kops called NodeUp that handles all of this, and everything is handled on the instance level as well. So the binary will be pulled from the community repository and dropped off on the instance. But as kops grows, that binary will also grow. And so in a weird way, it's a component of kops, but it's also a standalone Kubernetes bootstrapper within itself. That's all abstracted out to a YAML manifest. Yes?
Are there any networking upgrade paths from kops 1.4 to 1.5? Like, could you sort of use the same cluster and upgrade to a private topology?
I have not done that before. I think we talked about it when we first started looking at private topology. But in theory, it should work, yeah. Interested to see if it works for you. Yes?
Would that kops binary that's driven by the YAML configuration be useful on something like a bare metal server?
I think so. And as we start looking at things like Azure and Google and bare metal moving forward, that's the reason NodeUp was designed the way it was, is so that we can essentially take advantage of that same logic and use it as a generalized Kubernetes bootstrapper. OK. Looks like our API is coming up. Kubernetes dashboard. Less glamorous of a moment here. And you guys will get really tired of looking at these dashboards by the end of the night. So let's wait for Kubernetes to process the dashboard. Give that a couple seconds. There we go. Yay, the dashboard's up. Great. OK, so looking back at this, we now can see that we've actually brought this up to life. We can go into AWS. We can look at the subnets. We can look at the security groups. We can look at the VPC. But as I mentioned earlier, the bastion we should be able to find here in our instances list. And yeah, there we are, all the servers. So again, any questions, anybody, before we move on to the most exciting one, which would be HA? Yes?
So to SSH to the nodes, do you have to set up any SSH config to do the hop through bastion, or how's that?
So kops, let me back up. So kops can take an arbitrary SSH key. If you don't specify one, it checks your SSH. Or actually, I think it defaults to home SSH ID RSA. But if you could do SSH forwarding into the bastion, and then you could hop, because the bastion, let me go back, is available in both utility subnets for each of those. So you could then hop to the master of the nodes from there.
So you can do your own SSH or something that's handled by...
Sure. We can do one really quick if you want to see. So we would grab, I'm just going to grab the load balancer one, but there is a Route 53 record put in for us as well. But I will just bypass that and use this since I'm already here. We use Debian, so admin at. So now we're on the bastion server, and then we could grab a private IP address of one of our servers in here. Admin again. Yes. Oh, what happened here? Did I not minus A? Oh. You guys are getting to watch me fight with Unix here.
What was the name of the repo that you have all that stuff in?
Chris Nova / kops. Kops demo. For some reason, it doesn't look like my SSH agent is getting forwarded.
Happily.
Thanks. Getting to watch me learn how to use SSH live. OK, there we go. We're on the master. So let's destroy this one and move on to HA clusters. Actually, it looks like we are there.
Hey, Chris, I got a question.
Sure.
What version of Kubernetes are we installing tonight?
152.
It's 152?
Mm-hmm.
So that moved into stable? Literally, that's awesome.
Yeah. OK, great. So let's validate that our shell script looks OK. And we'll do a quick compare on our kops flags again. The only thing you'll notice this time is we're going to be specifying multiple availability zones for our nodes as well as our masters. Kops will do the math. So if we have, say we wanted to deploy 6 nodes here, and we had 3 availability zones, you're going to get 2 nodes per zone. And then I think it just does the first one it can take advantage of and make it as even as possible if there's any awkward arithmetic there. So anyway, we will specify the master zones as well as US 2A, 2B, and 2C, which those are available to my AWS account. It's specific per account. So just because I have A, B, and C doesn't mean you guys are going to have A, B, and C. And that will actually run an HA control plane across those availability zones with a private network topology, and then it will load balance across the 3 masters. So from the command line, who asked about the repository? Did you find it OK?
Yeah.
OK. And we can go ahead and take a look at this example as well. Very similar to before, you'll notice that we're creating multiple master subnets across the availability zones per region. That's fundamentally the only difference. You'll notice that the AWS resources are created dynamically under the hood to support this new configuration. And kops is smart enough to detect if you're using more than one availability zone to go ahead and run your cluster automatically in HA. So if we wanted to take one of these masters down, the ELB will catch that automatically and balance traffic between the two. Because each of the masters are in an ASG, if a failure does happen, like Netflix Chaos Monkey, for instance, and the instance itself crashes, AWS will automatically recreate that for us.
And then the etcd is just automatically linked together. And
It's part of the bootstrap process, yeah.
Not if a node not a master gets replaced, right? How would you get the new one into the etcd cluster?
I think it'll sync from the other ones, because etcd will be running in HA as well.
Could etcd be a separate component in kops? Or no?
So this is a question we've seen before, and I think it would be fine. I personally, and everybody's subject to have their own opinion. I have no qualms with it. We would have to do a little bit of under the hood, behind the scenes work on pulling etcd out into what kops calls an instance group. An instance group is sort of the ambiguous name of an autoscale group with networking attached to it as well. It's like a kops-ism. And the reason it is vague is so that as we start to grow into Azure and Google and bare metal and other clouds, the instance group terminology will remain uniform regardless of the platform. But how that would work if we did decide to code that in as a feature is we would actually pull that into an instance group and deploy it that way, in which case etcd would essentially mirror this layout right here as well. OK, that one was a little bit faster. So here you can see I'm using kubectl. So what kops is doing, I don't think I've mentioned this yet, is it'll actually generate our kube config for us and drop it off on our local file system as well. So just by deploying a Kubernetes cluster, you're going to get your kubectl right there already for you. So again, we're EOFing, so we're waiting for the cluster to bootstrap itself. Any other questions on this diagram or anything else we've covered tonight? Yes?
Is the underlying OS of the nodes
out of the box, kops will ship Debian if you don't specify otherwise. There is a -- image flag that you could pass to here. So it would essentially look, and then, oh, if I could type some AMI ID. And then you could just create that AMI through any process and then bootstrap your own.
Is there anything specifically needs to be done when you're creating that AMI or golden image other than just being a Debian flavored distro?
What ETH tool, is that the big one for Weave that we've noticed?
So if I could add some color, Chris.
Sure, go for it.
Currently we support Debian, Ubuntu, RHEL, Alpha, and CoreOS. So I would recommend using the community-based image unless you're really good. Let's just
But
leave
in,
it at that, because we've got about 16 dependencies, a custom kernel depending on the EC2 instance type, Docker dependencies. Somebody made a comment that Kubernetes isn't easy to install.
Yep.
And yeah, use the community image.
Sure.
It works.
Any other questions? Yes?
Can I ask you a quick question about, you mentioned like the other cloud providers. Do you have any kind of timeline or plan for ways of?
Well, we would love to invite everyone here to start contributing to kops in their free time. I think, so there is in the repo, and this will sort of speak to the timeline. You know, and I'm going to do it. I'm going to drill down into.
You're really gonna do that.
I'm really going to go here.
This is good.
Um,
I'm currently telling Justin that he needs to merge.
so here's our code. So we have AWS up and AWS tasks. These are representation in Go of the actual resources we apply. And then the way kops is set up is it's interfaced out to not care about the cloud. So we call create, and it doesn't matter. We do have code in GCE. I haven't touched it. Last person I know who actually successfully deployed a cluster was about a month ago. So really, I think all we need is we need somebody to come in and sort of own that and drive it and bring it to life. There's a lot of interest in Azure right now, I know. And then I think bare metal is on the horizon as well. When that'll happen, I think it's going to pretty much that's going to be determined by when we get people into the kops code base who really have a use case for it. So please, come to kops and help us code this and make it great for the community.
I'm curious about the Terraform output. I played with it, and I'm curious what the intended workflow would look like for that. I get that it can describe the current state of the cluster you've defined in kops and the Terraform scripts. How would somebody utilize that, given that kops is doing so much other stuff?
So the workflow I've heard of, that I know a lot of people are quite fond of, is using it as a starting point. So what the Terraform output for kops, and we're getting a speech after this on Terraform and kops in general, so I won't go too involved here. But essentially, the Terraform output that's generated by kops is a representation of the same resources that we're going through tonight. Which that allows the community to do two really powerful things, which number one, use Terraform to rationalize that, and any of the other tools you can use to audit and understand that. And then also as a starting point for things like before we had kops supporting private subnets and customized subnets, for instance, that was a really great way to say, here's our vanilla cluster, and I can hack on and prototype and play with it, and then kind of figure out what we need. And then we can bring that back to kops if we need to. So those are the big use cases that I've seen people use. But again, I don't know. I would love to hear more about what people use Terraform for. Yes?
What is kops running like the kubelet and the API server binaries from? Is it systemd, or are you guys running containers that are running those pieces?
Containers.
Containers, okay.
Cool.
Kubelet's running outside. But the memory's not across them, right?
Yeah.
Okay. But yeah. Why would we?
Just curious. You're using systems.
No, you're fine. We're waiting on the API now. Hey, API is up and running. So we're going to do this for one last time, and then I'll be done, and we can take a break. Generate our dashboard. Poof. Let's grab our URL. And our password. There, dashboard to an HA Kubernetes cluster, private topology on AWS. Any other questions about anything cops related? Anything else I can help with? Yes?
Are you going to allow it to block at some point?
Allow it to what?
Allow it to block?
Block what?
Allow cops to block as it develops the cluster?
Oh, that's actually a really good question. So I think what you're asking is, would we ever want cops to not behave asynchronously and actually behave synchronously? So there's an issue out now for a minus wait. And we do have a concept of cops validate that we can thank Chris Love for. And essentially what the validate would do is that is the cops' official supported way of saying this is what we consider a valid Kubernetes cluster. So the minus wait flag would essentially hang until one of two things happened, either a timeout or we got an OK from the wait. So it would still behave asynchronously, but you could actually use cops to sort of spoof a synchronous deployment. It wouldn't actually exit and return back to stack until we either validated or timed out. Sure. Any other questions? Yes?
Is that engine 111.2 or 112.1 on those images?
I don't know.
So, yeah, so that's image stuff. As you notice, we have our sweet spot. Thank God she's around because I can't go with that AWS stuff. So there are defined images by Don Chen and Google, and that's what we run. So it's tagged on release. And right now we have a CDE open on 111. So, yeah.
Cool.
Hence my story about running.
Yes?
Does COPS have a story around upgrading an existing COPS cluster from, say, 147 to 152?
Yes, we do. So cops has oh my gosh, I can't see anything right now. So I won't even show you, I'll just tell you. Rolling upgrades is what you're looking for. So essentially what rolling upgrades does is it's handled by cops and will actually take down bits and pieces of the cluster one at a time and redeploy them with an upgraded version of Kubernetes.
So just the guy that is coding that right now is saying that you said what version to what version?
Like 147 to 145, or but arbitrary to arbitrary, perhaps.
Let's talk afterward.
You could show a cops edit cluster and just change the version there, right?
So you would only be able to do a cops edit cluster and change the version with a rolling upgrade. I don't think you could actually do an apply and it would handle it gracefully.
Is it possible to add extra bootstrap steps to these big scripts? Love to be able to do that. I mean, using the official images would be
Sure.
much easier.
So the answer is no, technically, although it's a feature I'm fighting for personally. So any help I could get from anyone helping design that, giving input on use cases, I think it would be really great. And ping me afterwards and I'll give you the issue number if you want to see it. But essentially my great idea is that we need to have some way of abstracting arbitrary logic, whether that's in Go code, whether that's a shell script, something, and COP sort of washes its hands of the cluster at that point, and then it's in your domain. Any other questions? I am going way too far over time, so I'm going to take my lead now if nobody has anything else. Great. Well, thank you so much for coming out.
I especially like how you're committing code while in an Uber. Yeah, and every demo you presented worked too. Yeah. We're gonna take a 10-minute break. So 7:45 we'll have Matt Brannion speak about Terraform.
Now is it on? All right. Okay. So what I'm going to be talking. How do you make this thing? I'm no good at this stuff. I'm good at the top on the right. I can't see that from here. Oh, awesome. So I put this together. I apologize. It's nothing pretty or anything. It's more or less to remind me what I should be talking about instead of what I'll probably try to talk about. So KOps, or is it? It's supposed to be cops, isn't it? I'm the weird one saying KOps, aren't I?
It's whatever you want to call it.
All right, well, I feel more comfortable with KOps because I'm strange.
It's Spock backwards.
So KOps and Terraform. A little background. I started off using Terraform. I reverse engineered what AWS was doing, the CoreOS folks were doing, put it all into Terraform so I had more control over some specifics around the bootstrapping and how we wanted our security groups to look, and adding extra features. That is the point we chose AWS over GCE. So using things like the Redis instances or Elasticache if you want, Redshift, we have some Kinesis streams we're using in there. All the things that AWS has to offer. So I saw KOps. It allows you to export its configuration into Terraform, which is great because it gives you that configurability, again, without having you have to manage it, letting someone else make sure all those configurations come out right. But I found that also kind of, well, I'm getting way ahead of myself here. This is who I am. I'm a data ops engineer at Zvelo. I've been working with Kubernetes for about a year, since I already went here. So what I'm talking about here is a mixture of using KOps and Terraform, using them both, instead of just kind of using KOps to bootstrap Terraform and then going from there. So I started off using target Terraform to give me that nice Kubernetes.tf file, and then I added all my other stuff on top of it, and then I ran it. But what I found is that it kind of sabotaged the benefit from using KOps, which is that it manages that cluster for you, like doing the rolling updates is a really cool thing. So for all the people who've been working on that, I love that. So I would be the person to say don't use target Terraform at all. It's not worth it. It takes away from what KOps is. It's still really neat, and I really like Terraform, though. So instead of Terraform, why not using AWS CloudFormation? Has anyone here actually used CloudFormation?
Oh,
It is horrible.
at least they support YAML now.
They do? I'm still not going to use it. It takes 30 minutes to take down a cluster. It takes like 10 in Terraform. They should just call it CloudFormation, but run Terraform in the background. It would work so much better that way. And why not just using Terraform all the way like I was doing is, well, because KOps has really nice features to it. I think that really adds to the whole managing clusters thing. I think what is it says on the main thing? KOps is Kubernetes for Kubernetes. It allows you to manage those clusters and just repeating myself, but I like it. All right. So why would we use Terraform on top of KOps? And this is where I was getting ahead of myself, is that we can add those services that would make more sense to let AWS manage than attempting to run them ourselves or in the cluster or whatever. Like for instance, I want to say it's Redshift. I mean, you can run Postgres in your cluster, but the pricing on actually running Redshift is a lot less expensive. We also tie into Dynamo. Managing AWS IAM users and roles for all of our microservices is actually really neat and easy to do with Terraform. This has actually been one of my pain points, is KOps likes to talk about cluster auto-scaling, and it's all in the repos and everything, but it's missing one key policy to where it doesn't work out of the box and you have to kind of go digging. Did you guys fix that? The PR's in, but I'm not using that yet. I'm still on 144. No, that's great. But maybe there's some other policies that need to be added or taken away, because I have some, it's all outside of this, some gripes with the actual cluster autoscaler itself. There are other ones out there, but they require permissions to be slightly different, or at least coming in from a different place. And that's really easy to switch to when you're using Terraform. It's really easy to modify the components, so you can kind of manage kops, your Kubernetes version and everything on one end with just kops. And it won't affect anything that you've created with Terraform. And then you can go into Terraform, you can add users, take away users, upgrade to a new version of Redis, and it won't mess with your actual Kubernetes cluster. And it's really easy to clean up, which I like. So, because I'm bringing clusters up and down all the time. So I created, oh man, I spent so much time trying to get that to fit, and now it doesn't fit. It was just perfect in there, but oh well. I'm sure you guys can figure that out. So I just created a quick little repo that has this information. I seriously just threw it together earlier today, so I hope there are no typos. I wasn't taking an Uber, so I didn't have time to fix it. So here we just have kind of the steps to go through. Would you guys like for me to actually run through this in a terminal so you guys can see it? Instead of just talking about it? All right. Let's. All right, so this is where I was going from it earlier. There we go, not gonna need that. Okay, bigger?
Blind people can see.
I can appreciate that.
2 more.
Thank you for being specific about it. All right, so this is my repo here. Not much going on in it. So what we're going to do first is we're going to create our kops cluster. Please tell me if I misspell something, because that's probably going to happen. Oh, yeah, I forgot cluster in there, huh? I'll get to it. Also, the name, GitHub does this nice thing where it just suggests random names for you. And I thought that was more fun.
It does what?
Yeah, when you go to create a new repo, it'll suggest just a random name if you don't have a name for your project. You can choose it or not. I mean, yeah, isn't that like the best feature ever? So I got solid Telegram because it makes no sense. Oh, so this is the same thing that Chris was showing earlier. Really nice and real quick. I guess I should have done the --es. Oh, but I have in my notes here. This is where you would make all your changes like you normally do. And now we'll create the cluster. And it'll take a minute to come up. And in the meantime, I will show you guys what I have set up, just as kind of the demo for Terraform. This is just a simple, single, nothing fancy, no security cluster. So if we go into the Terraform directory, we will see, look at him. That makes more sense. Is this all right? All right. So the folders, or the files in here. We will look at the main first. For the things that we're setting up, there are only a few things we need. We're going to need for Redis, this the subnet ID, and I think the node security group. Yeah, the node security group ID. The node role is used only for cluster autoscaler. Everything else it doesn't need any more information than that. I just threw in, well, region I have to use for Terraform to know where we're doing something. Availability zone, and my information for Redis.
If I can ask a quick question.
Sure.
This Kops contributor knows absolutely nothing about Terraform.
Yep.
So we are not embedding the variables for you for region?
So if I did a target Terraform, you guys would create all that, and it's a Kubernetes.tf file. I'm not doing that. I didn't do a target Terraform. These are separate Terraform files that I've created, and I'm basically importing the cluster by giving it the subnet, the security group, and the node role. That's all cluster autoscaler needs to know to create the IAM role policy is the name of the node role, and for Redis, it just needs those other two things. So yeah, it's not a lot. And before, when I was doing target Terraform and adding all this stuff to it, I had to go into all the other files and add the subnet as it was named and everything else, and that was actually more of a pain because those names were really long. Some of the TF files we have here, I'll list it a little easier. So we're going to create the cluster autoscaler. This is just going to be the, like I said, the IAM policy for it. I'll go over the config maps after in a second. We're creating a Kinesis stream and a Redis instance. We're also creating some IAM users, and we'll go over that. Actually, we'll go over that before the config maps because they're related. So if we look, this does not look pretty here. I created really just two users using Terraform's configuration stuff here. An S3 access user. It just has the three parts, the user, the policy, and the access key. It creates an access key that we export later. And one for Dynamo access. Dynamo is not something I think that you'd want to create per cluster. Instead, you'd want to have one per region, I think, and then attach to them with all your clusters in that region. And actually have an example of how to make sure it's kind of namespaced out there for you. And if we look in config maps, TF, it's using Terraform templating to create an EMV file config map and an AWS users config map so that we can import those into our deployments and pods later on to actually use them. Well, I'll just cat these out. So AWS users, nothing fancy there. I'm sorry, it's not a config map, it's a secret.
What did you mean by importing them into your pods?
You're going to want to look up config maps and how to use them inside Kubernetes.
Oh, gotcha.
Sorry, yeah. So then the pod grabs all that stuff, and what was the other ENV? Nothing fancy. We actually have a huge list of these that we use and everything else. So it is still not up. Make sure it's going right over here. Now it's quiet. I'm sorry, guys. You guys have any questions I can answer while I'm into this? No questions?
Would it be useful if Cops would spit out the Terraform output that would import the existing Cops cluster into Terraform for you?
Yeah, if it could throw out like a, I don't know, because that would require Cops kind of to know more about the AWS infrastructure that you're trying to create. But if it would at least kind of pop out, you know, the VPC, the subnet IDs, and just those general IDs for AWS when it's done. That would make importing a little easier. Unless there's, I mean, it'd be great if you guys did everything for me, and I'm sure everyone here would agree. But I mean, that, yeah, just know what I mean with it is all. Yeah. So yeah, as you can see, we have quite a few clusters going here. It's not working. There we go. Okay. So now is going to be time for questions because it takes a while to create a Redis cluster. We don't really have to follow through with all it, but I have to give it the command. We'll do a plan real quick to look at what it would create for us. No, I don't have. So all the stuff in green are the things it's creating. We'll go through the list. So now we do a Terraform apply, if you're familiar with Terraform at all. And it's going to go through and create each single thing. And when it's done, we can export those config maps templates. I always export them into a YAML, then I can automatically apply them to my Kubernetes cluster. I have Terraform export a config map template.
So it exports the YAML for you?
Yeah, it exports the YAML for me. I just pipe that into another file to keep in our repository to track all that stuff. Yes?
So are you doing that at that point as part of your Terraform as a local exec, or is it just another step that you do?
Oh, I have an error here. Oh, I forgot the really important bit. It's one of the, I think it's a provider of Terraform is a template file. It's not a local exec. It's
I'm meaning the application of that against your Kubernetes cluster.
oh no, I do it manually. I could do it as a local exec, but I don't. I just haven't gotten to that part yet. So I didn't change the subnets from earlier, so it failed out on me. I need to grab the subnets real quick. So let me get rid of this. Actually, that was right. Sorry, I'm trying to find the subnet ID here. Where'd it go? Oh, there it is. And too many guys. Terraform is really neat for when I make mistakes like this in front of a lot of people even. I'm still having problems.
Is your availability zone correct?
I did 1A, didn't I? I typed 1A, but I should have done 1B. Thanks. But that wasn't, I think, in there. Yeah, I did 1A here. Totally worked earlier when I did it, when no one was looking. All right. Not embarrassing at all. Actually, I've seen worse. They've gotten a lot better at it.
So you can't import the Kubernetes Terraform state or to get any of this from a remote state?
You mean, so Terraform actually does support importing. I could import the subnets, but that also gives Terraform control over it. And that's not what I want to do.
Importing the state or value. I'm still using an older version of Terraform. We used to call it remote state, where you could see the S3 bucket or wherever you store your state. If you could import that remote state and then access the output from that. Give you access to that, and we could just use that data without having to change it on the fly.
I don't know if it would be any different.
Cops is storing that in a Terraform state file.
I don't think it is, because it's not using it in the background. Oh, one thing here. Over here.
I was asking if it was stored anywhere, if cops use Terraform, you could get to that state so that you could get these variables from that.
Oh, I just have an invalid.
That's what we were talking about earlier with kops generating potential Terraform output to import an existing kops cluster. There's an issue out kind of searching on that.
Subnet.
Terraforming, it allows you to pull in
Oh,
cloud state into Terraform.
weird.
We haven't coded it yet, so it's whatever we want.
Yeah, I found the problem. I have no idea where that subnet came from. Hope I got my other stuff right too. I knew I should have staged all this beforehand and just made it look like I knew what I was doing. And I probably did the same thing with the security group. So let me, yeah, I think I grabbed the wrong security group.
I know you were bashing CloudFormation a bit, but with CloudFormation, if you use Terraform, Troposphere, you can use Python, you can use the Boto library to query your clusters and get all the information that you want, so you can write your CloudFormation out. Maybe it is. Just a lot of things like read it from that to anything you want from AWS.
I'm sure CloudFormation.
Python.
I'm sure CloudFormation is a lot better than I'm giving it credit for.
Troposphere is nice because you can write it in Python, you can do loops and stuff.
Yeah.
So you can programmatically output your JSON rather than having to write JSON, which no one really likes.
Can you dry run that?
That's actually really neat. I just my goal was to be messing with what it takes to get a cluster up and running less and actually manage the cluster and get our code running in it. This is mostly just what I settled on. So yay, I got it right. And the last cache is creating. It will take a while, but in the meantime,
I'm a little confused on the use case. Do you use kops to scan a cluster and then
Right.
you're trying to stand up like ancillary resources and then
correct.
set up IAM to have
Access to those resources.
access to those resources, and you're using the config maps to configure the cluster itself?
I'm using config maps inside Kubernetes so that my services inside Kubernetes know how to talk or have permissions to talk to those outside services.
So you're configuring, you're just basically putting in some data that you're going to be able to load into your services.
Right.
So that you can talk to the ancillary.
Right. I find it's a lot easier to manage this with Terraform, especially on cluster cleanup, which I'm going to show here in a minute. Was it projects? I was Everything was working. What happened?
Is it hot?
Did I overheat it?
Yeah, it's beeping at you now.
Neat.
Display stuff.
Demo gods.
Because I was giving such an amazingly successful demo, maybe it was just sparing you people from the rest of it.
Well, let me ask you a question.
Sure.
Um, it's an evil question because I ask it to all the people that use Terraform,
Yep.
and I really hope you have a solution. How do you unit test and integration test your Terraform?
I don't.
We use sub-accounts for that. We use sub-accounts to set up the whole Terraform structure completely so we can test it, because there's no way to unit test the Terraform very easily.
You do what?
Create sub-accounts to link billing accounts. When you wave, you can have another account. You can create a full structure of production. So you can make changes there, because doing this stuff in production is painful.
Well, and I fibbed. I've contributed to Terraform. Yeah. So, has anybody seen a solution for it? Like, I'm genuinely asking because I feel pain. Oh, all right.
I generally just do it kind of manually.
I'm not dogging Terraform, by the way.
No, I understand.
You know.
And that was one of the nice things about moving to this kind of not using Terraform for absolutely everything. Was that I know all the stuff's working because mostly in trusting KOps.
Maybe you could listen how you guys do those same tests with cops against AWS.
You wanna? That's okay. So, very good question. Very cool stuff. Google has a AWS account. Let's just let that simmer for a second. So there's a bunch of different, there's a PR process within Kubernetes, right? So we put code into Kubernetes, it gets tested. Every time a PR comes into Kubernetes, kops runs. Kops runs against AWS now, and does E2E tests. So we create clusters every time a Kubernetes PR is put through into Kubernetes core. A AWS cluster is now created, torn down. 90% of the E2E suite is currently running, and we're shooting for 95.
That's the same for cops as well. So every cop PR also uses itself to deploy it.
Right, but like it's running the latest kops code, not even a stable code, so it's testing kops.
Right, but couldn't the same argument be made for Terraform? Just out of curiosity. So
Yes.
the argument we're making is
It's not
that
an argument.
you have to
I told you
spin
this.
up